So today is lesson 4.2. All these little things going on. There we go. All right, so next we're going to actually in class do the experiment to test the effect of sugar, which is an energy storage molecule, right? Sugar is glucose, so that is a type of energy storage molecule. It contains energy on yeast, and yeast is a living thing. Okay, we'll talk a little bit more of that at the end of class, but yeast is actually a living organism. To test the effect of sugar, you'll see you'll actually put different amounts of sugar into 3 cups. Cup A, cup B, and cup C. So before I go on, I'm going to just kind of pause here so that we can get our materials and actually do it as we go through as it comes. All right, so here's our first step. Our first step is to put no sugar in cup A. You want to put a pinch of sugar in cup B and a teaspoon of sugar in cup C. So a pinch is literally a pinch. So take your sugar cup and literally put a pinch into cup B. In cup C, you have 2 measuring spoons. The teaspoon is the smaller of the 2. So you're going to take the smaller of the 2 of the sugar still. Yep, and put a scoop as level as possible into cup C. You're just watching the video, Phoenix? Is that the deal? Okay. Everybody good? All right, we're going to put 1 tablespoon of yeast into each cup. So 1 tablespoon, so that's the big one. And the yeast is the brown stuff. Try not to make it overflowing, okay? So you want it to kind of be level, so shake it a little bit so it's level. And hopefully I have enough for all of our cups. If not, I got more yeast over here. In all 3. Yep, all 3. And then next, we're going to put some warm water into each. So if you look at your graduated cylinder, you want to find the 40 mark. Let me just double check that. That's 40. And you're going to put 40 into each cup and then use the popsicle sticks to stir. Doesn't have to be exact. So about 40. And then stir each one. Yeah. Do you want, there'll be sound, you can turn it off. Would you want headphones? Okay. So once you get 40 in each, then use the popsicle sticks to stir. You can leave the sticks right in each cup. That's why there's 3 of them. So that you're not adding stuff from each one. Oh, I guess my heat works again. I had no heat yesterday and now today. Okay. You guys are my experimental group because when I left here yesterday, I said, oh, we'll just watch the video. And then this morning on the way in, I'm like, I cannot watch the video. So I set it all up this morning, but I didn't test it. So I don't know if my yeast is dead. I'm hoping it's not. So once you stir them all up, then just set it back in the tray. And we're going to set the experiment aside for a while to give the yeast time to reproduce. Okay, so the yeast is a living thing. The sugar is an energy storage molecule. And remember, the yeast, living things need energy to reproduce. So that's what we are looking at. The goal of the experiment is to find out if these differences in the amount of energy storage molecules, or the sugar. So remember, 1 cup has no energy, 1 cup has a little bit of energy, and the third cup has the most energy. So does that have an effect on how much energy the yeast can release? So is it more energy, more reproduction, or is it doesn't matter how much energy? Okay? If you're not going to get the yeast to dissolve, you just have to kind of stir it around. You just leave the stick right in it. Yep, it's okay. I see it. All right, so we're going to skip this for a moment, okay? Because we need to wait for it to reproduce. So we'll just give it a minute here. It does stink. Does anyone bake? Nobody bakes. Yeast. And they make sourdough. Yeah. So does sourdough have yeast though? Does it? Oh, you're right. Yeah. I was gonna get into that over COVID, and then I never did. Over COVID. Like, we got all this time. Let's try sourdough. All right. So we are gonna leave those to sit, but let's see what happens in the video. We'll skip all the setup.
All right, we're going to do the yeast mix.
We just watched all the setup. Or you just did it all, I should say. All right, we'll start from here. Oh, 15 minutes, they're saying. Okay.
15 minutes, we can check on our results. There's cup A that did not have sugar. There's cup B that had a pinch of sugar. You can see it's increased the volume quite a bit. Here is cup C that has a full teaspoon of sugar. Filled the entire cup. Camera down so you can see together. So you got quite different results.
Okay, so I'm going to leave that like that. In your laps, open up your Chromebooks and go to the number 2 for today, because it's obviously going to take some time to sit. And we're going to hope that my yeast isn't dead. But regardless, we got to play with water and sugar and yeast. So we're going to open up the number 2 for today. And you're going to want to open up the document there. So here's our number 2 for today. And each cup had the same amount of yeast and water, but different amounts of sugar as listed in the table. A had no sugar, B had 1 pinch, and C had 1 teaspoon. So the first question, which cup of yeast showed evidence of releasing the most energy? Explain your answer. And which cup of yeast most likely reproduced the most? Explain your answer. So I'm going to put that picture back up for you. And you want to answer those 2 questions. And we'll let our experiments kind of sit and see what happens, if anything. I'm not impressed so far, I will say. Is this C? Last year when we did this, this is what happened. So if it doesn't work, it's got to be yeast. Oh, and it says it expires May 15th, 2020. It's not open though. Come on. I don't believe it. I have yeast in my cabinet that's expired. It still works. We'll try it out. I'll try it out next period. So you should be answering the two questions. Which cup released the most energy? Why do you think that? And which cup most likely reproduced the most? Why do you think that? When you're done, you can turn that in. Set them aside so they're out of the way. So as we saw, not necessarily in front of us quite yet, but in the video, the yeast in cup C appeared to grow the most because they produced the most bubbles, right? So the video that you saw, cup C, had the most bubbles. The bubbles are carbon dioxide from a process called cellular respiration. I mentioned this briefly. Is the smell bothering you? Do you want me to take it away? A process called cellular respiration, which releases energy. Because we saw bubbles, we know that the yeast released energy. Okay, that's what the bubbles show, that there's energy being released. But we don't yet have evidence that the yeast actually reproduced. Okay, just because it got bigger, that doesn't mean that it reproduced. Those were just the bubbles forming. This image was taken through a microscope. It shows the yeast reproducing. To reproduce, yeast cells grow buds. So this is a yeast cell, and when it reproduces, it creates this bud here. And they get bigger until they break off and become new cells. So all these little bumps that you see, these little brown bumps, those are buds that are beginning to form. And so as the yeast produces those buds, and they break off, and you get more and more yeast. Scientists have observed that when yeast gets more energy storage molecules, they can make more buds. That means that they can reproduce more. So now we're going to watch a quick video about an experiment in which scientists gave crickets different amounts of sugar, then observed the effects on the crickets' reproduction. This experiment is similar to the one that we're doing with the yeast. Oh, I once had crickets for our geckos. It was horrible.
We're going to do an experiment to investigate how cricket reproduction is affected by the amount of sugar crickets eat. Sugar is a type of energy storage molecule. Crickets and other organisms can use sugar to release energy. They need to release energy to move around, avoid predators, and reproduce. Crickets reproduce by laying eggs. In our experiment, we're going to examine two groups of crickets, Group A and Group B. We'll give these two groups different amounts of sugar in their food and see how that affects their reproduction. We'll give Group A food that's low in sugar. Group B will get food that's high in sugar. Let's leave the crickets and check back in 4 hours to see what happens.
I hate crickets. Oh.
4 hours have gone by. Let's observe our results.
They're like spiders to me.
Now we can see how much each group reproduced by counting how many eggs they laid. Group A, the group that received less sugar, laid 10 eggs. Group B, the group that received more sugar, laid 50 eggs. The group that got more sugar, Group B, reproduced more. This is evidence that when more energy storage molecules are available, organisms can reproduce more.
All right. No. Stop.
We're going,
All right. So, which group of crickets reproduced more? Whoa, I'm getting the B group, right? Why did the B group reproduce more? Got more sugar, right? So the more sugar they had, the more energy storage molecules they had, the more they could reproduce. So the yeast experiment for some of us turned out okay, not as great as the video, and I think that's our yeast, but I have to investigate a little bit. Some of us can see that cup C actually does have more gas being produced, so more energy is being used than the other cups. And then the cricket experiment as well, together give us evidence that the more energy storage molecules available to a population, the more the organisms in that population can reproduce. Okay, so we're going to attach that then to our jellies when we see each other or at your at-home lesson next week. All right, your baskets, I'm going to have you take over to just find any place over there for me to clean them up. And then you are free to go. I will wipe down your desks for you as well.